Okay, the back page starts with another verify identity. Same rules though. Start with the more complicated side, and I see that obviously is going to be on the right. This one that you're not going to have an option on is going to have a half angle or a double angle, something that is not the Pythagorean identities, and that's what you need to keep an eye out for. Especially since I see a double angle here and I see a double angle here, this is suspicious to me. So 2 sine t cosine t, if I look at my identity sheet, that is sine 2t. Secant 2t, well, the same rules again should apply. I want to turn everything into sine and cosine. So secant is 1 over cosine. So secant 2t is going to be 1 over cosine 2t. This is in the numerator. This doesn't have a denominator, so it's over 1. So I'm going to have, when I multiply across, sine 2t over cosine 2t. Well, sine over cosine is always tangent when they have the same variable going on. So we have 2t, sine 2t, or excuse me, tangent 2t, which is what we were trying to do. We're done. So give me a smiley face. Give me something that says, hey, this is what we were trying to do. Then it gets a little bit harder. Find the exact value of the following given. And in your head, you should say, oh, they want me to draw a triangle. So sine alpha, a, whatever you want to call it, sine is opposite over hypotenuse. And it says it's between pi and 3 pi over 2. Well, if you don't like that, you know that pi is 180 and 3 pi over 2 is 270. They're really just telling you what quadrant we're in. So we're in quadrant 3. Oh, and there's another variable, which means they want a second triangle. So cosine of beta, we have an adjacent and a hypotenuse. That's going to be between pi and 3 pi over 2 also. So that's also going to be in quadrant 3. And I went from Roman numerals to Arabic numerals, but that's okay. So I have to draw my triangles. And just like you, sometimes I make mistakes and try to draw my triangle and I realize, okay, wait a minute, I'm in the 3rd quadrant, so I stretch that out. So I start with A, and I think, yeah, I used A and B here. I didn't bother with the alpha and the beta. So sine is opposite over adjacent. I knew the negative had to go with the 1 because it went down, and our hypotenuse is always positive. I did the Pythagorean theorem. Got square root of 8, which can be and should be simplified to 2 radical 2. It's down here. So 2 radical 2 is our other side. It's going to the left, so it's negative. For B, same concept. It's the same numbers, negative 1 and 3. The negative is going to apply to the 1 because it's going to the left. And if you do the Pythagorean theorem, since these are both sides, we're actually going to get the same value. This will be 2 radical 2. It is going down, so it will be negative. With that having been said, now we have to plug it into the formula on your sheet. So the sum formula for sine is sine A cosine B plus cosine A sine B. Use the triangle to find the sine of A. So the sine of A is negative 1 over 3. Put it right there. Don't take sine. Sine of A is negative 1/3. Cosine of B, do the same thing with the beta triangle. Plus cosine A in the alpha triangle, sine B. And then we multiply. Well, negative 1/3 times negative 1/3 is positive 1/9. Negative 2 times negative 2 is a positive 4. Radical 2 times radical 2 is radical 4, which is really just going to be 2, because the square root of 4 is 2, over 3 times 3 is 9. Well, 2 times 4 is 8, and with everything else being the same, we have 1 plus 8 is 9, over 9, anything over itself is 1. So we write that on our little answer bar, and we are done. Number 6 is a backwards problem. I want to say you had one similar to this on your quiz. So we have a problem that matches up with cosine squared A minus sine squared A. And if you look at your identity sheet, that equals cosine 2A. So now, since it's backwards, we'll have to work backwards. Well, what is A? A is 15. Plug it in over here. So we have cosine of 2 times 15, which is cosine of 30. Look on your unit circle, and that is radical 3 over 2, and we are done. Please make sure you look at your half-angle formulas that require you to find what quadrant we're in. Just saying. 7.4. Express each product as a sum or difference. show all your work. So you have the product of sum formulas. Those were not on your quiz. Those are what you learned after the quiz by just watching a video, and you know that you just need to plug stuff in. So we have A, we have B. We plug it in. A minus B, A plus B. 6x minus 4x is 2x. 6x plus 4x is 10x. You cannot add those together because they do not have the same variable structure. You have to have the same variable with the same coefficient in order to add them together. So this is it. This is the answer. It's done. You cannot put cosine 2x with cosine 10x. The only thing you possibly maybe could do if you really, really wanted to was you could distribute the 1/2. But that's not necessary. If you did, it would look like this. You could not distribute it to the 2x or the 10x. It would just look like this. But why do more work than you have to? Same thing happens down here. We plug it into the formula. We add a plus b. We do a minus b. We cannot add them together because they don't have the same coefficients of their variable. So we are done unless you really, really, really feel the need to distribute the 1/2. Take a look at the sum or difference to product formulas, but again, they're the same concept. You just plug them in. If you have any questions, email me or come see me before or after school. Good luck.